Question number 40. Armstrong Faber produces a standard number 2 pencil called Ultralight. Since Chuck Armstrong started Armstrong Faber, sales have grown steadily. With the increase in the price of wood products, however, Chuck has been forced to increase the price of the ultralight pencils. As a result, the demand for ultralight has been fairly stable over the past 6 years. On average, Armstrong Faber has sold 457,000 pencils each year. Furthermore, 90% of the time, sales have been between 454,000 and 460,000 pencils. It is expected that the sales follow a normal distribution with a mean of 457,000 pencils. Estimate the standard deviation of this distribution. This question is a little bit different in that we are given X, and we're given the mean, and we're given the mechanism to determine Z, but this question is asking us for the standard deviation. So we need to do things a little bit differently on this question. First thing is let's graph what our table looks like. So it's given us two X's, 454,000 and 460,000 pencils. And so if I were to chart this, $454,000 would fall out here. 460,000 falls right around here. Further, it says that 90% of the time sales fall within 454,000 and 460,000 pencils. So I'm interested in this, and we know, because we were told, that this represents 90% of our sales. What I'm going to do then is I'm going to figure out the standard deviation for this by using, it doesn't matter which one of these X's I use, but I'm going to use this one just because I think it would be a little bit easier to calculate. So I have 460,000 minus 457,000 divided by my standard deviation. Now the question is, how do I determine Z? Well, if this represents 90% of my distribution, that means that 5% of my distribution is here, and 5% of my distribution falls right here. Because I want to get a z-score of 460 or less, I'm going to take this 90% and add this 5%. I want to look up the z-score associated with the probability of 0.95. In my z-table, I look for the probability closest to 0.95, and that happens to be somewhere in between 0.94950 and 0.95053. 0.95 is closest to 0.94950, so I'm going to use a z-score of 1.64. So now I have 1.64 equals 460,000 minus 457,000 divided by a standard deviation. 1.64 equals 3,000 divided by the standard deviation. I now need to simplify. My first step is to multiply standard deviation times both sides. Sorry for the messy writing. So this cancels out this. And so I end up with 1.64 times standard deviation equals 3,000. And then I divide each side by 1.64, which gives me the standard deviation equals 3,000 divided by 1.64, which gives me my standard deviation equals 1829.27. So this is my standard deviation for this problem.